Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about compound interest. So compound interest is, and I've got a little definition over here. Compound interest occurs when interest is paid on both the principal amount and on the accrued interest earned. So we're really talking here about people putting their money into savings accounts with a particular interest rate. And when that interest rate is compounded, it increases way more than it would if it was not compounded. A really simple way to explain it is we could have simple interest or we could have compound interest. And compound is going to be way better when it comes to money we earn, right? Because obviously you want to earn the most interest that you can on any given savings account. So for simple interest, that would be, just take for example, let's say I put $1,000 in the bank and I only have simple interest, which just doesn't typically happen, but let's just say that it did. Let's say I had a simple interest of 10% earned. So I put in that $1,000 and after let's say it totaled monthly, right? After 1 month, my earned interest would be $100, right? 10% of 1,000 is $100. Not too bad. That's actually really good. But let's say the next month, because it's simple interest, I earn 10% on still that original $1,000 that I put in. That was the principal amount. So I only am earning interest on the principal. So again, I get $100, and that's great. And then again, for the third month, I also get 10% on the principal amount. So again, I get $100. Not too bad, right? I mean, that's quite a lot of money. $300 is not too bad. But let's look at the difference between a simple interest and a compounded interest. So in a compounded interest, if I put that same $1,000 into a bank account, for the first month, I earned 10% interest, right? So 10% of 1,000 again is $100. So far, same amount, right? No difference. But the second month, it not only will give me 10% interest on the $1,000 I had, it will also add in that $100 that I earned. So now it's not just $1,000, it's earning 10% interest on $1,100. And that gets 10% interest. So $1,100 times 10% would give me $110. And then the next month, I get to add that onto the amount getting earning interest. So instead of $1,100, now I've got $1,210. So when I earn my 10% interest on that amount, now this month I've earned $121, right? So that just shows you, just a little simple example to show you simple interest where we're just earning the same amount every single time versus compound interest where our amounts are increasing every month, which is a great investment strategy. We do have a formula to help us find compound interest, and it's pretty straightforward. We'll walk through each part. So the A stands for the total amount. Our P stands for our principal amount, and by principal, we mean the starting. And then we've got a 1 plus R. R is going to be our rate divided by N. And we actually have 2 N's. So then we also have this brought to the power of N times T. So both of these N's represent the number of times interest is compounded per year. Okay, and we'll look at kind of how that looks in just a second. And then our T, our last part, our T is time. Okay, so a couple key words that we're going to see in these word problems. Yearly. So if we see the word that it's compounded yearly or annually, then our n value, this n right here, would be 1. And that makes sense, right? The number of times interest is compounded yearly, well, if it happens yearly, that means it's only one time per year. So it makes sense that n would be 1. Okay, so what about semi-annually means twice per year. So our n would be 2. Quarterly would mean it would happen 4 times per year. Think of like how many quarters are in a school year, or how many seasons are in a year, right? Or how many quarters are in a dollar, right? All of those are 4. At least, where we are in school, we have 4 quarters. So n would be 4. Monthly, so how many months are in a year? Well, there's 12. So n would be 12. Weekly, there are 52 weeks in a year, so n would be 52. And daily would be 365, because there are 365 days in 1 year. There are words that I've seen show up quite often in these compound interest problems that I generally try to stay away from when I'm writing problems. And those words would be bi-yearly, biannually, and bi-weekly. Those words can be very ambiguous because one person take bi-monthly, right? Bi-monthly could mean every 2 months. Bi-monthly could also mean twice a month. When I'm writing problems, I try to be very clear to avoid confusion, but just so you know, if you come across a problem maybe in your homework or assignment and it says bi-yearly, bi-monthly, or bi-weekly, maybe just double check with your instructor to see what they interpret that as and go with that. But it could be a little ambiguous there. All right, so we are ready to finally jump into some problems. We've laid a lot of groundwork, and once we get into these problems, you'll actually see that they go pretty quick. Sam deposited $15,000 into an online savings account that earns 2.5% interest compounded yearly. How much money will she have in 10 years if she does not touch the account? All right, so let's think through this. Let's label, because they've given us every single part of our equation. So we want to know how much money will she have in 10 years. So we are wanting to know A. We want to know the total amount. And they have told us her P, her principal, her starting amount is $15,000. So I like to label that over on the side. P is $15,000. Then we've got our R, our rate. So they've given us a rate of 2.5%. So here's the thing. We can't put a percent into this equation. We need to turn this percent into a decimal. And how do we do that? Well, we take this decimal and we move it over 2 places to the left. So that ends up being 0.025. You could also just say 2.5 divided by 100, right? That'll give you 0.025, whatever your preference is. N, they told me it was compounded yearly. And what did we say yearly was? N equals 1. And lastly, we need our T. So our T is time. And so how many years are we talking about? 10. So our T is 10. So now we just plug it into the formula and see what we get. So we're looking for A equals P, we said was 15,000, parenthesis 1 plus, and on the top of our fraction is going to go our R, 0.025, divided by our N, 1. Close that parenthesis to the power of N times T, so 1 times 10. Now what's cool, some of you I know are looking at that and you're thinking, man, that is a lot of work right there. We can actually just put that right in the calculator. So if you pull your graphing calculator out, we can type this in. So let me show you how to do it. We would do 15,000 parenthesis 1 plus, and you can either put this in another set of parentheses, or a way to make a fraction in your graphing calculator is to hit alpha y equals. You want number 1, so you'd hit enter. And see how that creates a nice little fraction bar for you? So we can put in 0.025 up top, 1 on the bottom, bring our parentheses to the power of 1 times 10. There we go. We hit enter. There's our answer. So A equals 19,201 point, and then we're talking about money, so let's just round to the nearest hundredth. So 26, but we've got that 8 there, so that's going to bump that 6 up to a 7, so 27 cents. So we're looking at, in her account, she's going to have a total of $19,201.27. Let's do another one. Catherine currently has $3,500. If she is receiving 6.3% interest compounded quarterly, how much interest will she have earned after 5 years? So we've got to take careful note of this question because it's asking something different than what the previous question did. So the previous question was just asking how much total will be in her account. This question is asking how much interest will she have earned? Okay, so we're still going to solve the problem the same way. We're still going to use the same formula, but we've just got to be really careful that we are answering what they're asking. We'll kind of worry about that at the end. So we again are going to use that same compound interest formula. I'm going to bring it over. So that was A equals P parenthesis 1 plus R over N, close parenthesis, to the power of N times T. Alright, so they've given us everything we need here. They told us her principal amount was $3,500. Or $3,500 if you'd rather say it like that. They've told us that her rate is 6.3%. So her R is 6.3%, but remember, I don't need a percent, I need a decimal. So we take that decimal and we move it over 2 places to the right, or we take 6.3, and I'll just show that real quick. We take 6.3 and divide it by 100, right? 0.063, whichever way works for you. For our N, we've got to pay close attention. So they said the interest is compounded quarterly. And remember, we said quarterly would be N equals 4. There are 4 quarters within a year, right? Or 4 seasons, or 4 quarters in a school year. However you want to think of it, however you want to remember it. N would be 4. Our T is our time, and she wants to know how much interest she will have earned after 5 years. So T is 5. So now we just want to plug in to the formula. So we've got A equals P 3,500 parenthesis 1 plus our R, so 0.063 over N 4, close parenthesis, to the power of N 4 times T 5. All right, let's bring out the calculator to make quick work of this. So I'm going to type in 3,500 parenthesis 1 plus, and remember, we can make that quick little fraction if we do alpha y equals enter. Okay, 0.063 on the bottom, and the denominator is 4. We're going to close that parenthesis out to the power of 4 times 5. Let's see what we get. So we see that A would equal 4,000 $784. And remember, we want the nearest hundredths. We're talking about money, so we want our cents. So it would be 0.14 cents, but we've got that 8 there, so that bumps the 4 up to a 5. So we've got and 15 cents. Now, a lot of people, when we move too fast, right, myself included, sometimes we would stop there, we'd circle that as the answer, and we'd keep moving. The problem is we haven't actually answered what they've asked. So they said, how much interest will she have earned after 5 years? So this is not our interest amount. That's just the total in the account after 5 years. So we've got to really think about this. She started the account with $3,500. Now we have $4,784.15. So how much interest is earned? Well, we need to find the difference between those numbers, right? So we want to take $4,784.15 and subtract from that $3,500. Right? And when we do that, we could do it by hand or we could just use our calculator. 4784.15 minus 3,500. And we get a total of $1,284.15 in interest. So that's how much she has earned. That's how much Catherine has earned in interest over these 5 years. All right, let's look at another one. John wants to have $20,000 saved. He is currently earning 1.83% interest in his savings account compounded semi-annually. How much money would he need to start with to meet his goal within 5 years? Okay, so they've asked us to do something totally different than the other questions did. We want to know how much money would he need to start with? Okay, so we have potentially the total amount, how much he wants to end up with. So here's the thing. First off, I'm just going to quickly jot down the formula, right? A equals P parenthesis 1 plus R over N parenthesis to the power of N times T, just so we remember what we're working with. So John wants his amount to be 20,000. So we actually know A this time. A should be 20,000. And then when they say how much money would he need to start with, well, that's our P, right? Isn't our principal amount the starting amount? So P is going to be what we're looking for in this equation. So we're going to have to do a little bit of solving in this one to find P. So let's go ahead and continue with the other values that we do know. So R, remember that's our percent. So that's 1.83%, but I don't want a percent. I want a decimal, right? So 0.0183. And our N says that is compounded semi-annually and would be 2. It means it's happening twice in 1 year. And then our T would be 5 years, right? And that our time, he wants to meet his goal within 5 years. So let's plug in what we do know to the formula. So A is 20,000. P, we don't know, so we're just going to leave it as P. 1 plus R, so that was our 0.0183 over N, 2, to the power of N times T, 2 times 5. So now how in the world would we solve that for P, right? Because I can't just type that into the calculator now like I did the other ones. This one's a little more challenging. So I'm going to have to figure out what can I simplify within this equation. And hopefully you're seeing that this 1 plus 0.0183 divided by 2 brought to the power of 2 times 5. I could simplify that part. That part's just being multiplied by P, right? So I could go ahead and just put that part in my calculator and just simplify it. So we'd put our parenthesis 1 plus, I'm going to use that little fraction, 0.0183. Denominator would be 2, and to the power of 2 times 5, or just 10. Let's see what that part is. Okay, so at that point, I have got 20,000 equals P times, and we've simplified this to this decimal. Now, I know you're tempted to round here because we're dealing with money. We don't want to round at all. We want a really exact answer. So I'm going to put this long decimal in. I know that's a lot. So 1.095360928. Okay, I don't want to round because I want an exact answer. So now this is really P times this long decimal. And how do I undo times? Well, I would want to divide. My goal is to get P alone. And so I would want to divide by what I want to cancel. So this really long decimal, right? Something divided by itself always cancels to 1. And if I divide by this really long decimal on this side, well, guess what? On this side, I need to also divide by this really long decimal. Now, obviously, I do not want to do that by hand. That would take me forever. So I'm going to use the calculator. I get 1/8. And I am talking about money, so now I'm going to round to the nearest hundredths. I'm at my answer now, so it's okay to round at this point. So that would be 82 cents. And I look at this 1, that 1 is 4 or less, so that means that 2 stays at 2. So it's just 82 cents. So let's see. So we've got our equals P, right? So what is the principal amount? Well, $18,258.82. So if we wanted to write it in a statement, we would say John needs to start with $18,258.82 in order to meet his goal within 5 years. Here's one for you guys to try. Yolanda has $300 to place into an account that pays 5% interest compounded quarterly. How much money will be in the account after 7 years if she does not touch it? All right, so I will post the answer in the video description below. This has been Miss Math Tutorials.